Dear friends, this is my tutorial 35. In this tutorial I am going to teach you how to calculate Gibbs free energy of reaction using Gaussian software. So in this tutorial I am going to explain how the Gibbs free energy calculation of N2 absorption on this HIPT molybdenum ligand. So I will show you that HIPT molybdenum ligand. So this is the input file for HIPT molybdenum ligand. So I will show you opening with the Gauss view. So open your Gauss view. Just we can drag that input file. So this is the HIPT molybdenum ligand. So we are going to use this ligand to absorb N2 on this molybdenum site. So I will show you this input file using Notepad++. Open with Notepad++. So this is that HIPT molybdenum ligand. So here you can see here first you have to put percentage CHK HIPT molybdenum .chk. So this is the first line. Second and third line you have to give memory and NPRO shared. So here I am using Windows version, that's why I mentioned 6MW. So here I mentioned 2 NPRO shared. If you are using Windows system, the 2 is enough. So if you are using Linux based system, you have to change according to the Linux configuration. So here I am using B3LP theory. This is the common keyword we have to give in the root section. Then we have to give optimization following frequency calculation. So first I am doing optimization. To check the frequency, I am putting here frequency keyword. So if you are getting negative frequency, you have to again optimize your system. Then you have to give one space. Then you have to give the system name. Then you have to give the space. Then you have to give the total charge. Here actually molybdenum is 3+. So that's why I mentioned this total charge is 0. So if you see that ligand here, so 3 nitrogen or 3 minus, so molybdenum 3+, so total charge is 0. So that's why I mentioned the total charge is 0, spin multiplicity is 2. So this is the Cartesian coordinate of that HIPT molybdenum ligand. So then you have to give space. Then you have to give the what are the atom present in light atom present in the molecule. Here carbon, nitrogen, hydrogen present. Then you have to put 0. Then you have to put basis set. So what are the which base set you are going to use for light atom? So here I am using 631 G star basis set for these light atoms. Then you have to give a 4 star. Then immediately you start that molybdenum, then 0. Then you have to put Lanel 2DZ. Then you have to put 4 star. So this basis set for valence electron. So then you have to give one space. Then you have to put molybdenum and 0. Then you have to put Lanel 2DZ. This is for ECP electrons. So if you are using any transition metal, you also give like that only in the base set sections. So that's all. So if you can submit this calculation using your Windows system, it will complete 5 to 6 hours because this is somewhat the big system. So it will take some more time. So after optimization, you will get this output file. This is the optimized output file for HIPT molybdenum. So this is that optimized one. So likewise, we have to optimize another system, that is HIPT MO-N2. N2 absorbed HIPT molybdenum ligand. So this is that one. So I will drag here. This is that input file. So here you can see this HIPT ligand with molybdenum and N2 absorbed onto the molybdenum site. This is the linear expression. So likewise we can also see that input file for this one. So this is the input file for HIPT molybdenum N2. So we need 2 things because we are going to absorb N2 on this that ligand. So this is the initial structure. This is the product. This is the product one. The HIPT MO is the initial structure. That means that is a reactant. So after N2 absorption, that is the product. So then similarly like HIPT, we have to give the memory and NPRO shared. Then you have to give the theory. What theory going to use? B3LP I always use. Here you have to put this general keyword like what you mentioned HIPT molybdenum. Then put optimization frequency. That's all. then you have to give space, then you have to mention the system name, then you have to give space. Here also you have to give charge, total charge. Here also 0, because that N2 is 0, neutral only, that there is no change in the charge. Then you have to give the spin multiplicity, then you have to give that HIPT MON2 ligand Cartesian coordinates. So this is that Cartesian coordinate. So then you have to give space. Similarly you have to mention what are the atoms present in the light atoms, then basis set 4 star. Similarly molybdenum and Lionel 2Z as 4 star, then space, then molybdenum and 0 and Lionel 2DC. This is that valence electron, this is ECP electrons. So this is for light atom basis set. So that's all. So you can also submit this calculation. This also it will finish within 5 to 6 hours. So if you are using Linux supercomputer, it will finish within half an hour, 1 hour, because if you are using Windows version, it take time. So that's all. So now we will see that output file using that Gauss view. So this is the optimized structure output file. So this is the one. So if you want to see the results also, we can see, go to result, you can see summary, we will see this kind of result here. So frequency calculation, spin doublet, that energy and everything we will get. The imaginary frequency is 0. So you should get a 0 imaginary frequency. That means your system is optimized correctly. Otherwise you have to re-optimize your system. So then if you want to see that vibration also, we can see. So for that what you have to do, just go to result and click vibration. You will see like this. So just you can start vibration. So you will see different kind of vibration. So if you want to see nitrogen vibration also, we can see. So maybe it will come 2000 something. Yeah, so you can see. So NN vibration is that frequency is 2135. So this is the N2 vibrational frequency. So that's all. So we have optimized HIPT MO ligand and HIPT N2 absorbed one. So one more things we need, that is N2 molecule only. So we need this N2 molecule. So next we have to optimize N2 molecule. This is the N2 molecule. So I will show you using this Gauss view. Just I will drag that input file. This is the N2 molecule. So we are going to observe N2 molecule on HIPT molybdenum ligand. So I will show you that input file. This is the input file. Similarly we have to give percentage HK N2, just 6 million words, and N quotient 2. Similarly B3LP theory and the same keyword what you mentioned for other things. Then you have to give opt and frequency, then you have to space, then what are the system name, then space, you have to mention the charge. The N2 is neutral molecule, that's why we are giving a 0. So here you have to be spin multiplicity 1. So this is the Cartesian coordinate of N2 molecule. Then give space, then give what are the atom present, only N is there, then you put 0, then put the basis set for this N, 631 G star we will use always, then 4 star, that's all. Then give some space and you can save this. You can also submit that calculation. It will finish within 5 minutes, because it's very small molecule, only 2 atoms. So I will show you that output file using Gauss view. So just to drag that dot out file. So if you want to see result and vibrational frequency also, you can see this is the result one. If you want to see vibrational frequency, you can also see. So here you can see 2458. This is the vibrational frequency of this free N2 molecule. We can start vibration. See, we will get this vibrational frequency. Then we can stop, close it. That's all. So before going to calculate that Gibbs free energy, we need these 3 intermediates. So we have to use these 3 energies in order to calculate the delta G. So now I will tell you how to take the energies from this output file. So first we will see HIPT molybdenum. So just we can open that output file with Notepad++. So this is that output file for HIPT molybdenum. So I will already save that energies one of the Notepad+ one file. So this is the one. So I will tell you how I took that energy. So I will tell you only one, then you can follow other things also. So I will tell you that HIPT MO. So I did not mention earlier, just I will mention this actually. MO. Okay, that's all. So this is actually HIPT MO. So you have to go down. So you have to take from the energy where means, so I will tell you, you have to go that place, you can take that energy. You can see that a maximum force, everything converged. You have to get this SSS, then only your system optimized. So this is, you will get the end of the optimization. So you can, I will show from here, I will see, you will get your energies, optimized energy. Yes, you will get now. Yeah. So I will show you. So then it will start that frequency calculation. Before starting frequency calculation, you will get one paragraph like this. So here you can get your the electronic, that is the energy of total energy of this molecule. So that is this one. HF equal is that, that this is the one, minus 524.1611387. You have to copy this energy. So I already copied this one. So here you can see this is the 524.1611387. This is that energy I already copy pasted here. So I will tell you only one, just you can follow this one and you can copy for this N2 and MO N2 molecule also. So then one more things we have to, this is the first one you have to take, then you have to go to the frequency calculation section. So for that, where you have to go, just to go down. So you will see that you can see the frequency starting frequency calculation section. So here only your frequency will be print. So from here you can go down. So after completion of this frequency data, you will see the thermochemistry tag. See, this is the thermochemistry. From here you have to take your 0 point energy, E total, H correction and G correction. These are the very important. So I will tell you where to take this kind of data. Okay, from here you have to go down. So you can, if you go down, you will see like that, you will see these tags. So this is the important one. So 0 point energy, thermal correction to energy, thermal correction to enthalpy, thermal correction to Gibbs free energy. These are the 4 energies. So we are going to take these 4 energies. So here you can see I mentioned the 0 point energy. This is the 0 point energy, 0.225631. So this is the one I copy pasted here. Then I took the thermal correction to energy. So this is 236830. So this is the second one. So third one is thermal correction to enthalpy. So this is the one, H correction, that is E total. This H correction 23774. Then you have to check thermal correction to Gibbs free energy. This is the important one. So this is 0.188553. So this is the energy, important energy. You have to always take from this output file. That's all. So likewise you can also see that HIPT MO N2 system. Likewise you take that DFT energies and 0 point E total, H correction, G correction. Likewise you can also check N2 molecule. You take that total energies of N2 molecule, 0 point energy, E total, H correction and also G correction. Sometimes the small molecules you will get that G corrected value is negative. So if you are getting G negative value, you have to add to the total energy. So if you are getting that positive value, you have to subtract that energy from this total energies. You should remember that one. So like that you can take all the energy. Here you can see I have corrected all the energies. So actually, so this is the first one is E0, means this is the E0 value. So then I have corrected with 0 point energy. Just I will subtract this total. I will tell you one. So I will tell you this HIPT-MO. So this is the HIPT one. Just I have subtracted this energy, so I got this value. Then you have to subtract with this energy with the E total, you will get this value. So likewise you can subtract this value with H correction, you will get E0 H correction value. So likewise you have to do this, subtract this value with this one, you will get this value. Likewise you have to do for N2 and HIPT-MO N2 also. You do like that, you will get this list of data. So here we are going to use only this E0 H correction. This we can use this calculation of enthalpy. So this correction we will calculate that Gibbs free energy. So likewise you can take your energies. I will zoom it. You can see now easily. So I think you may understand now, I think. So this is that G correction. Actually this is a negative, this is also negative. So we have to add this two value to get this one. You can see, just you can do it yourself, you will understand easily. So that's all this part. So now we will go to the calculation part. Likewise you can take energies of, if you have any different large pathways also, you can do it similarly. So then we will do the calculation. So this is that delta H and delta G calculation. So if you want to do that delta H or delta G calculation, you have to put your product here minus reactant energy. So here product energy, reactant energy. Simply you can subtract this two energy, you will get delta H. So for that you have to use that H, that is that enthalpy value. So in the here I calculated the two kind of value. This is that enthalpy. If you are going to use that calculation of enthalpy, just you can use this value, only these values. So if you are going to use free energy calculation, you can use these values. That's all. So I will tell you while doing this calculation. So this is the delta G. Here you use the delta G energy of product, delta G energy of this reactant. So this is the first, we will calculate the delta H. So this is the very easy only. So I mentioned here E0 plus H correction product, E0 plus H correction reactant. Already we have corrected this kind of things. So we have the energy. So the simple reaction is here. You can see here HIPT-MO N2. This is the our product. Okay. So this is the our product. So reactant is that HIPT-MO and N2. So N2 going to absorb onto the molybdenum, we will get this HIPT-MO N2. I think you understand now, I think. So then we have to take that energies of these things. So you can see now, I will show you that one easily. So this is that H correction energy. Here you can see I took that energies of HIPT-MO N2. So that is the energy is this one. So you can see 633486744. This is the HIPT-MO N2 energy, system energy. Then we have to use the HIPT-MO energy. So HIPT-MO energy is 52392334647. So this energy. Then we have to use the N2 energy. So top one is N2 energy. So minus 109.5118134. So we need to add this two energy. We will get this value. We will get this value. Then so this is the same energy only. There is no change. So we are going to add these two energy. We will get. Then we can substitute into that calculator, or substitute. We can subtract this two value. So we can use calculator. So just copy paste. So here you can see we will get the minus 0.051563. so this is the we can substitute, we will get that energy. This unit is Hartree unit. Okay, the unit is Hartree, so we need to convert into kilocalories per mole. If you want to convert this energy into kilocalories per mole, you need to multiply with this one, 627.5095. this is the conversion factor value you always use. So we can multiply with that one, we will get minus 32.36 kilocalories per mole. You can see, so this is the delta H of this reactions. So if you want to calculate that delta G, similarly you have to do delta G also. So here I mentioned that HIPT MO N2 system and HIPT MO here and N2. So likewise delta H, so you have to substitute your that G corrected value. So where is this the G corrected values? So this is the our G corrected value. You can see E0 plus, so G correction. See here, so this is the first HIPT MON2 is 633.5416.274 this energy. Then you have to put a HIPT MO ligand energy, then you have to put N2 molecule energy, then you can add these two energy, put here, then you can take directly this energy, put here, just you can subtract these two energies, you will get 0.0355543. so this is the one, so I already did. So then we have to multiply with this conversion factor value, that means we will convert Hartree into kilocalories per mole. Just multiply with 627.5095, you will get minus 22.31 kilocalories per mole. So this is the delta G value of the formation of this N2 molecule. So this is the simple things, just you can do it and you calculate yourself if you want to do any kind of reactions. So this is very simple only. I will share this document to you, just you can use it. So I took this this model calculation from that Gaussian website only, so I will show you where to get that document. So if you have any doubt, just you can go to read that document, you will understand more easily. So you can go to Google, just Gaussian thermochemistry, you will see the first one, thermochemistry in Gaussian. So you will get this page, just you can see view PDF file of this paper, just click it. So it one PDF file will open. So this is that PDF file, just to go down. So this is the thermochemistry output from Gaussian. If you read this one, you will understand easily how I calculated also. So here you can see many things, just you can read it, you will understand. I followed this text only to show you that examples. So you see here, they also calculated delta H and delta G. I just followed this one only, so you can read it, you will understand easily. So thank you so much for watching my video. If you like my content, please like, subscribe, comment and share, and also please click the bell icon for my future video update. Oh, thank you so much for watching. Please subscribe and share to your friend, please. Thank you.